Hello students, now let us understand hashing techniques. Now there are three different types of hashing techniques: divisive method, mid-square method, and folding method. We will focus on what do you mean by divisive method and how to do coding for divisive method. Later on we will understand about the collision concept, and together we will try to build a C program for these two methods. So divisive method with collision resolution technique, which is linear probing. So let us focus on divisive method now. Now, divisive method is one of the hashing techniques where for a given hash table, we hash each key with the divisive method with the formula K mod M. So here, this is the formula that helps us to calculate, to find out the hash key for a given table. Now here, K is the key and M is the size of the hash table. So our formula for hashing technique becomes h of k comma I, which will be equal to h plus I. Sorry, this should be k plus I. So this is basically k plus I, the key that we have taken, plus the value of I mod M. Now here I is always 0 initially, and we can then later on increment the values of I depending on the size of the table. Here M is the size of the table. So if let's say M is given as 10, so we are going to perform modulus by 10. Okay, now let us take one example for this. So for given hash table of size 10, insert the given keys in it using divisive method. So these are the keys given and the size of the table, that means the value of M here is 10. Okay, so let us try to understand with this given problem. So first let's take key 22. So the formula for divisive method, as we know, that it is h of k comma I is equal to k plus I mod M. So we will put the value of key, that is 22, in this formula, and then we'll calculate the remainder for that. Now, initially you're going to show your hash table with respect to all the sentinel values. So we are going to represent here -1 for all the indices values. As you can see, our table is of size 10, starting from index 0 till 9. And all the values in the hash table are -1 initially. Okay. Now, if we want to insert key 22 into this table, so we'll have to put it in the formula to find out the index for that key. So for key 22, our formula becomes h of 22 comma 0. 0 is I, as I mentioned earlier, I is initially always 0. So 22 comma 0, which will become 22 plus 0 modulus 10. And we know that 22 modulus 10 is, we'll get the remainder as 2. That means 2 is the index value where we can store key 22. So you can see here in our hash table, the key has been stored at an index 2. Let's talk about the second key, which is 23. Same, we'll apply the formula on 23, which is h of 23 comma 0, which means 23 plus 0, which gives us modulus 10. That is, the remainder is 3. That means this key will go at an index 23. And similar way for 24, we will get the remainder 4. That means 24 value will be stored at an index 4. Then 25 will be stored at an index 5. Depending upon what size of the table is given, you're performing modulus operation and you're finding out the index value where we can store that key. So your index value is nothing but the hash value that we are getting in our hash table to store that key. So here in similar ways, we are storing 26, 27, 28. So the keys are stored according to the hash key values that we got after applying divisive method on that. Now, let us understand a scenario where, let's say we are getting a key which is 42. Now, if I apply it in the formula, so 42 comma 0, which will be 42 plus 0 modulus 10, which we know for this particular formula, we'll get a remainder as 2. Now, as I mentioned earlier, we are going to store the keys in the hash table when that entry is having a sentinel value. So if I want to store 42 at an index 2, I need to see that if this position has a sentinel value, which means earlier I did not store any keys into that position. But as of now, you can clearly see 22 has been stored at this location. So here, this this kind of problem where another key comes which is also mapping to the same address, right? Now this concept is called as collision. Collision means what? That there are two keys which are mapping to the same address in the hash table. So for the given hash table, at an index 2, 22 is also coming and 42 is also coming. So at any given point of time, if I try to put 42 into the location, it is going to overwrite 22, which is not right, right? I'm losing the data. So what should I do? So to resolve this problem, there is a concept called as collision resolution. Okay, so there are various techniques under that. We're going to learn one technique that comes under open addressing concept. So there is a concept called open addressing, which is also called as closed hashing. So under that, there are three techniques that are used to resolve collision. We are going to learn about linear probing to implement it in a C code. Okay, so what do you mean by linear probing? Linear means linearly or sequentially you're searching the position in your given hash table. So linear probing means to probe, to search particular location, and linearly means sequential. So let us understand this concept that if I am not able to store 42 at the same location because already there is some other value, where should I store that 42? So I need to search linearly to the next available location where I can store. You can clearly see that all these positions are filled. So the next available position is this. But how do I get that? Now for that, we use linear probing. Now what linear probing does, it finds the next possible location in the hash table by incrementing value I. Now, if the space is already filled for that next value of I, you keep incrementing that I value till you find the next possible position. That means here, once I increment I value, it will go to third position. Here also the space is not empty. So we will go to the fourth position, fifth, sixth, seventh, eighth, till we find a position where we can actually store that value. And for that, for the given formula, what we do is we increment the value of I. So the same formula where we are writing h of k comma 1 is equals to k plus 1 mod m. Now this 1 is because we have incremented the value of I, because we're not getting the new address for I equals to 0, right? So in the earlier problem, when I tried to search for, index value or a hash value for my 42 key, so it was showing index 2, which is not right because it is going to overwrite 22. So I need to increment this value. So the 0 value needs to be incremented to 1, right? So in the next uh, phase, what I'm going to do is I'm going to increment that I value to 1. So now the key, which is 42, and the value is I, which is 1, and I'm going to apply the formula on that, which is k plus 1 mod m. So for 42, it will be 42 comma I, which means 42 plus 1 mod 10. Now 42 plus 1 is 43, 43 mod 10 is 3. So I need to search at this location if I'll get any sentinel value, which means the space is available. But you can clearly see this is already filled with some value. That means we can't store 42 here. That means we have to search the next possible location, which means we'll be incrementing I. So from 1, we are incrementing the value of I to 2. That means 42 comma 2. That means 42 plus 2, which is 44. 44 mod 10, so the remainder will be 4. So we are going to search at an index 4. Again, at an index 4 also, we are not finding a sentinel value. That means we have to increment I. So we're going to increment I to 3. Likewise, 3, 4, 5, 6, we're going to keep incrementing the values of I till we reach to this point, right? So this value is, if this is 0, that means here I value was 0, right? Then here I value was 1, then here it was 2, then it was 3, then 4, then 5, then 6, and then 7. That means when the I value will become 7, we are going to find the position which is having sentinel value. So here, when the I value is 7, sorry, again there is a mistake. This should be 7. So I is 7. So 42 comma 7. So what is 42 comma 7? It is 42 plus 7 mod 9. So 42 plus 7, which will become 49. And 49 mod 10 is the index value 9. And we can clearly see at an index 9, there is a sentinel value, means that space is available. So we are going to store 42 there. So 42 will come at this location. Okay. So this is what the again, as there is, sorry for the mistakes. There are some typing mistakes in the slides. So sorry for that. Okay. Now next, let's talk about 43. Now I want to store 43. Right. So again, we'll start from 43. 42. Okay, now let's start with, let's say, a key number 99. I want to store a key 99 into this hash table. Okay, so we'll again start with the same process. We will start with I as 0 and we'll try to search an available space for that. If the available space is not available, hash key is not having a sentinel value, then we increment I. So here 99 comma 0, because I is initially 0, which comes as 99 plus 0, which is 99 mod 10, which is 9. And we can clearly see just now we stored 42 in that location. So this space is full now. Now what to do? Because does it mean that our table is empty now? Sorry, table is full now because we have reached to the last index. So no, it's not like that, because if you see here, there are some initial values which are empty. So here, when we perform mod operation and modulus 10, that means we are bringing any value to the range between 0 to 9, right? So let's increase the value of I. So now I will become 1. So after incrementing value of I becomes 1. So 99 comma 1, which makes it 99 plus 1, which will be 100. 100 mod 10, we know that the remainder will be 0. So you have to search it in location 0. So if you search at location 0, the value is minus 1. That means it's a sentinel value and therefore we can store 99 at that location. So likewise, you can see you can store number of keys into the table. Now just remember that because it's a hash table and we are representing hash table in our memory as in 1D array right now. So if you declare this array or a hash table of size 10, that means you can store 10 maximum keys into it, right? Any key beyond that will be not stored in the hash table because your hash table is already full. So these are the precautions that you have to take care of while you are designing your hash table. And we're going to implement hash table by using 1D array in memory. So let us see the program for that now. So let me just open online compiler. I'll just delete this code as of now and I'll clear the output. So first of all, let's declare header files that we will require for the program. Also here, what I'll be defining constant max with the size of the table, which is 10. So I am considering here hash table of size 10. Let's write a main function now. Now in main function, what are the things that we will require to create our hash table? So first is, because hash table, we are considering it as a 1D array. So I'll create that. So I'll say hash table. And the size of this will be max because I have already defined that constant. Also, to iterate through this hash table, I'll require one iterative variable, which is I, then X. Then we will also require a key that we will read from the user. And then we will require a hash key that we're going to calculate out of it. Okay, so these are the few things that we will require. Now, the very first thing that we are going to do is we are going to declare our array, which is a hash table with all the sentinel values. So for that, we will apply a for loop. For iteration, I'm using x value. So if x is 0, let me just enlarge this part. Okay. So let's say x is 0, x is less than max, and x plus plus. And here I am assigning all the index values of my hash table as -1. So I've just assigned everything as -1. So here my hash table has been declared now, initialized with all the values -1. Okay. Now, first of all, we will take the keys from the user and we have to make sure that because our hash table is of size 10, so user should give keys which are either less than or equal to 10. So first we'll give a prompt to the user. So we will say enter, sorry, enter the number of keys to be entered in the hash table. Okay. And here less than or equal to 10. Okay, so we're going to just be to be at the safer side, we want users to give only 10 keys. And then now we're going to read the keys, but because we are going to ask for 10 keys, so we need a for loop for that. So again, I'll use the same variable x for that. So I am not using, because we're using I function in our hash, I variable in our hash function. So I'm not using I here, I'm using x. So x is less than max, or yes, x is less than max, x plus plus. And here we're going to read those n keys from the user. So we can just say printf enter key, and we will simply scan that key. So %d address of key. Now once we read this key, we're supposed to calculate its hash key, right? So hk is the variable I have used to calculate the hash key, and we know the formula. The formula is take the key value, plus it with I value. So we need your I, and we have not initialized it. So first of all, we'll have to initialize I as 0. Okay. So we're going to initialize I as 0. So we'll say that key plus I modulus max. Max is the size of the table that we have, right? So we're going to get this hash key. Now we know that this hash key, before storing that hash key, we should have a -1 value. And if it is not, then we're going to keep incrementing the hash value. So we can apply directly a while loop, that we are saying that till we do not find hash table of hk not equal to -1. So we are saying till we do not get this entry, right? We have to increment the value of I, right? So we'll say I plus plus, and we'll say hk, again the same formula, hk key plus I, because we're going to increment I, and then perform modulus with max to get that value. Okay, and once we will find that particular position, that means your loop ends over there. So we're going to store in that particular entry of hk the key. Simple as that, right? So initially, when I calculate hk, and if there is no collision, so basically this condition will become false at that particular time, right? Because every entry is -1 in the initial phase. So this condition becomes false. So automatically we will not go inside the while loop, and we'll directly store that key into hash key. Only once we'll start getting the collisions because of the same keys mapping to the same address. Sorry, multiple keys mapping to the same address. That time our while loop may become true, and we are going to inside and incrementing I plus plus and checking if the position is available. Otherwise, we'll keep adding it to the table. Now, this is the loop, the code, that logic. Now, after this is done, what we do is we'll simply, once all the keys have been read and all the data has been gone to the uh, hash table, let's print it. So I'll say hash table. And here I'm going to print the index value along with the key. So I want to print something like this. So I'll apply the for loop again because it's a 1D array. So I'll have to iterate through it till all the max values. And internally, I can just print. So basically, I need to print the index value of the hash table and the key value. So I'll say %p colon %p. So in this format, I have to print it, right? So first value is the index value, which is x here. So in your table, it's x value. And the key value is the hash table's x value. I'll just put a /n over here so that it comes to the new line. I hope I have not done any mistake. Let me just run and check it. I'll just decrement the font little bit. Okay, so there are some mistakes I have done. It says, did you remember hash table? I think. Okay, I have hash table here. Also one more error, which is, yeah, I have used modulus. So modulus max, because we're performing mod. For mod, we have an operator modulus. Okay, now it's saying enter the number of keys to be entered in the hash tables, which is less than 9. And for that, enter a key. So let's enter a key starting with 0, 1, 2, 3. I'm giving simple values. We can clearly see that 0 will go to position 0, 1 will go to position 1, 2, 3. Now let's overwrite this and say 33. It should go to position 4. Then 4 will go to 5, 5 will go to 6. Now I'm writing 7, 8, 88. Now if you see the hash table, wait. I is 0 and then h of k is k plus I modulus k, and then we're storing the key into that. If not, then we are performing modulus and we are printing hash table of x. Now by it is showing all values 0, I think some mistake in my hash table. Okay, I think enter the values into the key. I have incremented I and yes, this is right. Everything is right. I have not just taken the value of max. Let me just write here the keys and I0 max x plus plus to the key. I found the error here. My loop is running from x equals to 0, x less than max, and this should be x plus plus. I hope it should work now. And one thing is, here I'm just writing enter the keys to be entered in the hash table. It should be less than or equal to 10. So the prompt I have changed a little bit. Also, I'll just make a /n so that everything comes in the new line. So basically, while printing the hash table, the loop is x equals to 0, x less than max, and x plus plus. So by mistakenly, I had written I here. Now let's run the code again. So enter the key. Now I'll try to give sequentially. So 0, 1, 2, then 3. So they will be stored at the same index value because same 6 modulus 10 is 6. Now let's override that. So 6 will go to the 7th position and 7 will go to the 8th position. Then 77 will go to the 9th position. So we can see here 0, 1, 2, 3, 4, 5, 6. 66 will go to the next position. 7 will again go to the next position and 77 will again go to the next position. Let's shuffle keys. Let's say I'm giving 45. So it should go to the 5th index. 67 should go to the 7th index. 89 should go to the 9th index. 12 should go to 2. Now I'm giving 77, 78. So I'm giving some random numbers. Let's try to compare them if they're coming right. So you can see I have added 45. So 45 has gone to the 5th index. Then 67 has gone to 7th index. So 5 and 7 is done. 89 has gone to 9th index. Then 12 has gone to 2nd index. Now 77 comes because we added 67 earlier. So 67 had already been there at the index 7. So 77 will go to the next index. 78 will also go to the another index because 89 was stored at location 9. So 78 will come to 0th location. Then 34, which is at the 4th location because it was empty. 56 is also empty, so 56 goes to 6th index. 10, because 78 is gone to 0th index, so now 10 will go to the next possible location, which is first. And then 8, because you can see clearly 8 is filled, 9th is also filled, 0th is also filled, 1 is also filled, 2 is also filled. So then 8 is stored at location 3. So yes, the program is working perfectly fine. And this is the code for hashing technique using divisive method and resolving collision using linear probing method. So thank you so much.